In this video, we're going to talk about the second integration technique that you have to know. It is integration by parts. So we're going to do one average difficulty question, and then we will do one that is very difficult. Just an introduction on integration by parts. You use integration by parts when you have clearly two items that's being multiplied together, and there is no way you can separate them or pull things outside. Think of it as the integration of product rule. You know, differentiation, you have product rule, right? You hold one, you differentiate another, plus you hold this one and you differentiate this one. Actually, how integration by part came about was from product rule of differentiation. What I mean is this. For example, you have two items. I want you to differentiate this with respect to x. How would you do it? You will hold u, differentiate v with respect to x, which is dv dx, right? Plus, hold this guy, differentiate this guy, right? You will get this. Now think of it this way. If you differentiate this, you get this. Meaning you differentiate green, you get red. What does that mean if you integrate red? If you integrate red, you should get back green. So let me just write the idea out. You integrate red, you will get green. Of course, you're integrating this with respect to x. You are supposed to split this into two pieces on the left hand side. You'll get u dv dx plus v du dx of dx. This is equals to u v. I'm going to bring this chunk over to the right hand side. I'll get this uv minus integrate v du dx with respect to x. You see two items on the left hand side. Integrating two items will give you uv minus integrate these two items. The questions that you face, everything you see here, one of them would be u, one of them would be your dv dx. So this is your starting point. This is where you start. You have to correctly identify which of these items is the u and which of these items is dv dx. If you identify wrong, you either be very hard or undoable. So take a look at this. One of them is u, one of them is dv dx. You have to choose accordingly. Sometimes it's not very obvious. So a general rule is to apply LIATE. This is the sequence of descending importance, meaning L is the most important when you are choosing u. Whenever you see logarithms, that will take priority over inverse trigo, algebra, trigo, and exponential functions. So in this case, this question, so LIATE, T is trigo, E is exponential, so which is a better candidate for you? The correct answer is this. This is your u, this is your dv dx. But we will do this question later on in the video. Let's start off with the first one. Here, if you were to use LIATE, you realize both candidates are both algebra. So this means that it will not make a difference which one you choose. Sadly here, if you choose this as your u and you choose this as your dv dx, you'll run into some issues when you are doing the question. Let's see. If your u is x cubed and your dv dx is this, you realize that you are unable to find v because you can't integrate this easily. So that's the issue, right? How do you rectify this issue? How do you integrate this guy? X squared plus 1. I can rewrite this as this. And if only there is a f prime x that's accompanying him, right? Right now it's missing. You can't just top up a 2x and write 1 over 2x like that. This is illegal. So we need to make a better decision here in choosing u. Instead of choosing this entire thing, which is very tempting because it's clearly two items, you should split this into x squared and x of x squared plus 1. So your dv dx will actually have an additional copy of x, whereas your u will be only x squared. This will help us integrate this way easier because now integrating of this, because differentiation of this gives us 2x. So we put a 2 here, we put a half here, and then this will become half of x squared plus 1 new power over new power. Simplifying this will give us just x squared plus 1, 3 over 2 over 3. And of course, du dx would just be 2x. Putting all this in place would give us integration of x squared, x root x squared plus 1 would be uv minus integrate v du. v du. How do we go on from here? This is already done, so we will just write this as this. Right. And then we'll take out the 1/3 and we'll integrate this. Notice this is already in the form of f prime x, fx to the power of 3 over 2. So this will recompile to give us just this, x squared over 3. Oops, sorry, this is to the power of 3. This is this to the power of 3. Oh, actually, you know what? I'm just going to write it as this. Easier. And then this would give us just fx to the power of new power over new power. X squared plus 1, 5 over 2 over 5 over 2. Simplifying this gives us that's it. So in the next question, this is very difficult because, now take a look at both candidates when we are choosing LIATE, right? Both of these candidates are pretty low on the spectrum. Yes, we will use cosine x to be our u and our dv dx to be our e to the power negative 2x. You should prepare yourself because this is going to get messy. If the both of them very low on the priority, you have to apply integration by parts twice and then bring things over. Okay, let me show you what I mean. So first of all, let's find du dx. This would be negative sine x. V will be integrate this, which would be 1 over the power. 1 over the differentiation of the power, and then copy, right? This will be negative e, like that. So once you've got that, this will be equals to uv negative minus integrate v du. So we get this negative sine x e power negative 2x over 2 with a negative. So negative, negative, no more negatives. Here, you have to use by parts again. This time around, this will be your u, this will be your dv dx. Of course, we want to put out the 2 and squeeze it here so that we have a slightly easier time. This is your dv dx. This becomes cosine x is your du dx. dv dx is e to the power negative 2x. Your v will still be negative half e to the power negative 2x, just like before. This will give us, here, I'll just copy. So here, I'll just copy this. This will be negative half cos x e negative 2x minus half. I'll get ready for a giant square bracket because here, I'll get the new uv minus integrate v du. So once again, minus v du. I'm going to clean up some of the items here. Negative half and this will give us plus half. And if we were to expand this giant square bracket, it will give us negative half cos x e to the power negative 2x minus half of this times this will give us positive 1/4 sine x e negative 2x. Minus half times positive half gives us minus 1/4 integration of negative e 2x cos x dx. Now let's take a pause here If we were to do this again, you run into the issue that, oh, this is your u, this is your dvdx. I'm going to do the entire by parts twice. Take a look at what this is equal to from the very beginning. This is equals to this, which is equals to this, which further simplifies to this whole thing here. Notice this is exactly the same item. You can bring this negative 1/4 over to the left hand side. This will give rise to 5/4 of integration negative e 2x cos x dx equals to negative half cos x e negative 2x plus 1/4 sin x e to the power negative 2x. So finally, if they ask you, what is this? You just need to divide both sides by 5/4, which will give you negative 2/5 cos x e negative 2x plus 1/4 divided by 5/4 gives you 1/5 sin x e to the power negative 2x plus c. Okay, so a quick recap to integrate this, where choosing u are both very low on the priority list, you will have to make use of integration by parts twice, once here and then once here. You have 3 items. One of these items will be a repeat of the left hand side. So we can bring this back to the left hand side and then collect them together and divide by a fraction to get our answer. Thank you.